I am Dr. Ashok Nayak. I am working as associate professor in the Department of ECE in the College of Marri Laxman Reddy Institute of Technology and Management. I am working from 2022. Now I would like give class in digital image processing subject. In this subject, discuss topic of digital image fundamentals and relationship between pixels. So, in this subject, now discuss points wise what is image, what is digital image, what is digital image processing, how many types of digital image processing, and what is relationship between pixels. Also, what is distance between these pixels. So these all are clarity given by in the today's class. So in the digital image fundamentals topic consists of mainly sampling and quantization, and also in this sampling and quantization, before I am going to discuss what is image. Image is maybe defined as two-dimensional function which is represented by f of x comma y. F of x comma y. X represents x, y is spatial coordinates. X represents one axis and y represents other axis. In between two axes having one point which is coordinate. Suppose for example when I will discuss on how represent image at a time, I will discuss about what is representation of image. Now x comma y is spatial coordinates or plane coordinates, and the amplitude of f at any pair of that coordinate having intensity or gray level value. So the field of digital image processing refers to processing digital images by digital computers, and which digital image composed consists of image elements or pels or pixels. But nowadays use word as pixels. Image consists of number of pixels, each pixel having some coordinate. So here in real time we have see analog image in the 3D, which image captured by camera, which analog image sensed by camera. So after camera can get image. In this, when getting image, having process having sampling and quantization. So after processed image is digital image. And now elaborate of view of digital image processing of digital image. So here fundamental steps in digital image processing, how many steps are there and what steps link between all steps of knowledge base. First one image acquisition. Second one, image enhancement. Third one, image restoration. Fourth one, color image processing. Fifth one, wavelets and multi-resolution processing. And sixth one, image compression. Seventh one, morphological processing. Eighth one, segmentation. Ninth one, representation and description. Last but one, object recognition. In these all steps, image acquisition to morphological processing, in between give input image and getting output image. In this all these 7 steps, what given input image, we can get a output image before processing a image and after processing also a image. This is specialty of these steps. And remaining 4 steps are morphological processing, segmentation, representation and description, and object recognition. In these 4 steps, given input image but getting output is attributes or features of these images. For example, when image enhancement, before enhancement, input is a image, after processed or some modification on image, we can get a output is image. This is a one type of process. And second type of process, given input image which output is having some features, what size of image and what intensity values are there and how much size of image, which is of second steps of image steps of processing. This is very involved all steps of fundamentals in digital image processing. This is very key points I discussed individually, having elaborated in next videos, because these all subject point of view in this knowledge base of image processing. And next, image fundamental subtopic is sampling and quantization. First of all, analog image is continuous sensor data into digital form. Analog image nothing but continuous censored data, and which converted to digital, it involves sampling and quantization process. And an image may be continuous with respect to the x and y coordinates, spatial coordinates, and also in amplitude. To convert into digital form, we need these 2 processes, sampling and quantization. And we have sample the function in both coordinates and amplitudes. But a very clear definition of sampling is digitizing the coordinate values is called sampling. And quantization definition is digitizing the amplitude values is called quantization. Here, majorly here discussing about these 2 terms, sampling and quantization. Basically, image having coordinates and which coordinate having some amplitude value. But digitizing coordinate is called sampling, and digitizing that particular coordinate amplitude value is called quantization. So here now 2D two-dimensional represented digital image f of x comma y. This x comma y is divided into n rows and m columns. So intersection of row and column is termed as pixel. Already I told you pixel nowadays very used term of pixel, which is known as image elements, which known as PELS, pels or pixel. So the one image consists of number of rows, number of columns. But here represented m is column, m is column, n is row. So here size of image having rows n into m. Here size of image is n into m. N represents row, m represents column. Suppose for example this first coordinate, first pixel is represented f of 0 comma 0. 0 first coordinate is 0 is row, 0th row, and second is 0th column, which represents first pixel coordinate. And there are computerized processed in digital image how types. First one low level processing, and second one mid level image processing, third one high level processing. So in these three processing of digital images in digital image processing, low level means one system is there, digital image processing system is there, input is image, output also a image. Which type of processing of images is digital image processing? Low level digital image processing. Second one, mid level image processing. In the digital system processing, input is a image, output is a features of that image or attributes of image. And third one is high level processing. In the processing, input is attributes of the image and output is image. What for example given here attributes of features, some height of and some color of, and image consists of two objects, like features are given into the input side, so which shape is circle shape and radius is some value, scalar value. So we can output is getting a some this features of consist is a ball, like that we can get a output, which is high level processing. These three types of image processing. Next, how is represent image? So in the image consist of number of pixels. So each pixel having coordinate. For example, f of 0 comma 0, f of 0 comma 1, f of 0 comma 2, f of 0 comma m minus 1. These all are these first row, and second row f of 1 comma 0, f of 1 comma 1, f of 1 comma 2, and f of 1 comma m minus 1. This is second row. Like that, similar, last row is f of n minus 1 comma 0, f of n minus 1 comma 1, f of n minus 1 comma 2, last but one f of n comma n minus 1 comma m minus 1. Means here rows, number of rows are there and number of columns are there. And here m minus 1 is columns and n minus 1 is rows here, according to that our representation. So when in the matrix, image always represented in the matrix form. In the matrix we know basically knowledge about matrix. From in the matrix starting from 0 to 0, 1, 2, 3 up to n minus 1 rows. Similar manner columns starting from in the matrix 0, 1, 2, 3, m minus 1. This is column. So in the matrix 0 to n minus 1, 0 to m minus 1. So here f of x comma y total image is represented by in the form of matrix form, which having some rows and columns in the matrix starting from 0. So here image size of image is what? N into m size of image. So which is very easy to representation image in the matrix form. And next, digital image processing fundamental is relationship between pixels. Relationship between pixels in digital image is one of view explain neighbors of pixels. Pixel is a one image element which is represented middle of 9 by 9 size of part. In the part middle is p of x comma y. In the p is represented some amplitude of this coordinate, and x is row, x is this row, and y is column, So above is some change row, and below is changes row, and left side of this coordinate p, left side change column, and right side change column. So for example, p of x comma y is one of middle pixel value, above, top, bottom, left, right. These 4 pixel coordinate is represented by n4 of p, which is called as 4 neighbors of pixels. These 4 set of pixels are called 4 neighbors of p. As similar, some other neighbors of p lies outside digital image if x comma y, p of x comma y, other diagonal coordinates is represented in same similar manner. in between middle is P of x comma y, and diagonal of right is change rows and columns. X plus 1, x row is x minus 1, column is y plus 1. Suppose for example P is x comma y, and top is row change x minus 1, comma y, same column, and below P of row change x plus 1, comma y, same column, and left P of x, same row and y minus 1 column. Similar manner, right P of x common and y plus 1. So these are n4 of p we know, but diagonally you can representation now. Same here, as similar, P of diagonal left, P of x comma x minus 1 comma y minus 1, and top completed, down P of x plus 1 row and y minus 1 column. Same similar manner here, P of x minus x plus x minus 1 and y plus 1 column. Next, down of right, P of x plus 1 y plus 1. So in the 4 diagonal of this P of x comma y, which are represented by nd of p, we know n4 of p and n8 of p. We know previously explained just before, n4 of p and nd of p. Union of these two is called n8 of p. n8, 8 neighbors of p. n8 is 8 neighbors of p. 4 neighbors of p is n4 of p, and diagonal neighbors of p is nd of p, and n4 of p union n8 of nd of p is equivalent n8 of p. This is in the mathematical form of these neighbors. So as before, sum of points nd of p and n8 of p fall outside of image if x comma y is border of the image, which is one property of this relationship between pixel. And also this distance between these pixels, for pixel p coordinate is x comma y, and q coordinate, q pixel coordinate s comma t, and z coordinate u comma v. These 3 pixels having 3 coordinates. So these 3 coordinates distance measure between each pixel. Some properties you can observe. D distance d p of p comma q. Distance p comma q mean is pixel p coordinate and pixel q coordinate between distance is need. So if p equivalent q, so No distance are there. P equal to Q. No distance. It is a one property, and distance P comma Q equal to distance Q comma P. Both distance are same. P comma Q or Q comma P, both distance are same. According to some formulas are there, we can prove with some formulas. And types of distances: Euclidean distance and D4 distance and D8 distance. So in the D Euclidean distance represented by dE of P comma Q equal to root of x minus s whole square plus y minus t whole square. So x comma y is coordinate of P and s comma t coordinate of Q. So distance P comma Q equivalent x minus s whole square plus y minus t whole square power of 1 by 2. So next distance is D4 distance, which called as city block distance between P and Q, same coordinates. So which is in the mathematical D4, D suffix 4, P comma Q equivalent mod x minus s plus mod y minus t. So this is a one of example of distance measure. And so next one, D8 distance of P comma Q, which also called as chessboard distance between P and Q. P coordinate x comma y, Q coordinate s comma t. Here represented D8 distance represented D suffix 8 P comma Q equal to max mod x minus s comma y minus t, which value is maximum between x minus s or y minus t. In between which value is maximum, which is final distance of D8 P comma Q. And also other type of distance is D suffix m distance. D suffix m distance also a defined as shortest m path between these pixels. In this case, distance between two pixels will depend on the values of pixels along the path as well as values of their neighbors. So here one example, according to example I will explain you. For example, here consider the following arrangement pixels and assume P, P2, P4 have value 1. This value 1, 1, 1 according to problem. P1, P2 1, P4 1. So these intensity values same. P pixel value 1 intensity value, P2 intensity pixel value 1, P4 intensity value 1, and similar P1 and P3 is there. P1, P3 problem continuation, and that P1 and P3 can have a value 0 or 1. Suppose that we can consider adjacency pixels values 1. Here, according to problem, explanation is 0, 1. You can substitute in either P1 and P3. Here P1, P3 possible to give 0 and 1. So two digits are there, two intensity values there, 0, 1. First you can give 0, 0. After that 0, 1. Next 1, 0. and 1 1. Four combinations to give in this problem. Then you can find shortest path. So here P1 0 and P3 also 0. Then find how find a path between P2 P4, only same intensity level to go path. Each two pixels same intensity level having distance is 1 according to our knowledge. So P1, P2, P2, 1 distance, P2 to P4 distance 1 means 2 is distance between P2 P4. P2 P4 distance is 2 and P2 P4 when give P1 and P3 0 1 case. First you can given 0 0 okay. Now 0 1 case. 0 1 case P2 P2 and P2 to P3 and P4. Distance here what how many? 3. And next 1 0 case. 1 0 case here 1 0 case P2 P1 P1 to P2 and P2 to P4. Here also distance 3. Next last case 1 1 case. 1 1 case P1 P3 case. On time 1 1 case here P2 P1 P1 to P2 P2 to P3 P3 to P4. Here distance 4. So which is shortest path? In the first case is shortest path 2. So here according to that we can find path between shortest path between P2 P4. So here main agenda objective is here of this problem is same intensity level to go either direction N4 or N diagonally ND pathway to find, but each between two pixels having distance is 1 and 0 don't consider, only 1 you can give consider to go way to find shortest path. Thank you for giving this opportunity to discuss about digital image fundamentals and relationship between pixels. Next, we discuss about image transforms and image enhancement by spatial domain and image enhancement by frequency domain. In the frequency domain, we can give more transform of digital images.